Hey, ladies and gentlemen, you guys are in for a treat today. We're going to do two lessons today. Woo! 11.1 and 11.2. Let's talk about exponents. So 11.1, I can write repeated values using exponents. Let's take a look. So, click in a to the b power, this right here. A we call the base, and the b part we call the exponent or power, right? A is the repeated number, and b is the number of times you need to multiply a by itself. Right? So the big number, the base, is the number that's repeated. The exponent or power is the number of times that you repeat it. All right, let's actually see what that looks like. So expand each expression. Let's write it. 5 squared. 5 squared is really 5 times 5. All right, that's all we have to do. That's what expand means. Just rewrite it like this. 3 to the 6th is going to be 3 times 3 times 3 times 3 times 3 times 3. That's it. That's how you expand. Just rewrite it as big. X to the third, it's going to be x times x times x. Y to the fifth, well, that's y times y times y times y times y. Couldn't be easier. Hey, look, 4 to the fifth times 4 to the third. How are we going to write that? In blue. Let's see. We're going to do 4 times 4 times 4 times 4 times 4 times 4. And then we're going to do, so this is being multiplied by the other one, so we're going to do times, and it's 4 times 4 times 4. That looks just like if it was 4 to the 8th. All right. 6, x to the 4th, x to 2. Same thing. I don't know what colors I have left. Let's go to orange since I started a trend here. X times x times x times x. There's the 4. Times x times x. Let's square our answers here. Those are all done. All right. So we can actually go the other direction too. To go the other directions to write an expression using exponents, we're going to write what we see, x, and then the little numbers made the number of times we see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, x to the 9th. 5, 1, 2, 3, 4, 5, 6, 7, 5 to the 7th. All right. Here, look, we have 2. There, a to the 4th. And b to the 5th. So this would be a to the 4th, b to the 5th. Here, look at this one. We have 2 to the 4th, x to the 1, 2, 3, 4, 5, 6, 7, 8, x to the 8th. Right? And sometimes they're out of order, so we could do this one. We could do 5 to the 1, 2, 3, x to the 1, 2, y to the 1, 2, 3. 5 to the third times x to the squared times y to the third. All right. Over here, same thing. 3 to the 1, 2, 3, 4. A to the 1, 2, 3. B to the 1, 2, 3. All right. And that's how you go the other direction. This is why we're doing two things. That is so easy. All you have to do is be able to count. Next page. Standard 11.2, I can simplify algebraic expressions raised to the 0 power or negative power. This is easy, guys, too. This day one's pretty easy here. So anything raised to the 0 power is really just 1. I'm telling you, it's easy. X to the 0 power, 1. 3 to the 0 power, 1. 3 times x to the 0 power, let's rewrite it. X to the 0 power is 1, so this is really 3 times 1. What's 3 times 1 make? 3. How about 4 times y, all raised to the 0 power? Well, the whole thing's raised to the 0, so that is 1. Oops, same thing. 6 times a, raised to the 0 power, 1. Ooh, 5 times m to the 0 power. Well, m to the 0 power is 1, so this is 5 times 1, which is 5. Then notice the difference. In 4 and 5, it's in parentheses, so the exponent's applied to both items. It's really 4 to the 0 and y to the 0, which is really 1 times 1, right? But 6 and 3 are not in parentheses, which means the 0 only applies to the x in this one. Here, the 0 only applies to the m. That's the difference, all right? A negative exponent flips the base and the exponent to the denominator, and the exponent becomes positive. All right? So here's what that means. X to the negative third is really 1 over x to the third. 3 to the negative 1/2, so we're going to just rewrite it like this. 1 over 3 squared. Y to the negative fifth, 1 over y to the fifth. 4 to the negative third, that's really 1 over 4 to the third. Sorry about that, guys. It flipped pages on me. This one gets a little bit more hard. The 5 stays where it's at. The x to the negative 3, just that part goes down. So we're going to have 5 over x to the third. Here we're going to have 7 over y to the fourth, because only the negative exponent affected one goes down. All right, here's the homework. Front page is the first part of the notes, right? Expand, and then write an expression using exponents. And then here we're going to deal with zeros as exponents, and then negatives, same thing you just did. All right,